all, welcome to our channel Way to Know. In this video, we will talk about the variation of propagation delay in the gates of a chip versus supply voltage variations and what it causes with respect to timing, or do we see any bit errors in the channel. So the first thing which we need to talk about when we are talking about a electrical circuit is the power, right? So the voltage, the supply voltage that we provide to the chip basically switches the required MOSFETs that are present inside the chip. So example, we see a MOSFET here. Let us assume this is a MOSFET which is present inside, and this particular MOSFET has a gate control which is provided. So the gate control is actually provided by some voltage level, right? This particular gate voltage level determines the switching speed of this particular MOSFET. Lower the voltage that is provided, it takes more time for the output to rise to the required level because of the capacitance that is present. And if we increase the gate level, it takes lesser time because we are giving more voltage to the gate. That means we are enabling the MOSFET to switch faster. Then the output reaches its desired level very quickly. So that means the supply voltage variation at the input of the gate plays a very important role in the propagation delay. And as we know, propagation delay is a very critical factor which determines the output success, right? So whether it be timing or any parameters, the error rates that we consider are all related to the delays, correct? So the propagation delay is very, very important. So when we talk about supply voltage, understand that your power supply variation is actually causing the timing issue in the PCB. Graph, as you can see here, the graph here, there is a V in that is being given, and we are getting a V out from a particular. So as we see here, circuit, this is the V in. You can see here, and this is the V out. The propagation delay we see that is causing out is not the signal to reach to its level at a certain time, and not because there is some capacitance that is associated, and the R and C time constant plays a role there, and to rise to its level. So for the output, you can see its required level, and the time for that should always be less than or equal to propagation delay. So this particular condition should always be met. And example, if the propagation delay increases, okay, that means let us assume the voltage here got lowered, okay, and the propagation delay increases at the output. What happens is it takes more time for the signal to reach to its level, and in that case the if this particular signal is related to another signal, for example clock and data together, this will cause timing errors in the circuit, which is very, very important factor to consider in the designs. So while designing your supply voltage, ensure that you provide a clean supply, and any switching that happens in the power supply shouldn't cause the propagation delay to increase and cause timing errors. Thank you.